In this lesson, we're looking at theory of logarithms, and here we're going to be applying laws of logarithm. And first of all, we are starting with the ability to convert between logarithmic form and index form. So if I have a to the power of x and is equal to n, this is called index form. To express this in logarithmic form, we write this as log of n to base a is equal to x. Recall that the logarithm of a number n, in this case, to a base a is the index x to which a must be raised to be equal to n. So if we apply that law, we'll be able to convert between logarithm and index form. The first question here says evaluate log 27 to base 3. Remember, this is a revision class, so I'm solving question right away. Anywhere there is a need for me to explain a law, I will explain it. There is not a full tutorial on logarithm. There's a link in the description of this video for that. So this is specifically for those that are preparing for WIAC. I'm using the WIAC syllabus. SS3 mathematics textbook, there's a revision part there, which is arranged according to the current WIAC syllabus. That is exactly what I'm using in this revision tutorial. So the first question we have to evaluate log 27 to base 3. If log 27 to base 3, let it be x. So that if we follow this rule here that says the logarithm of a number n to base a is the index s to which a must be raised to be equal to n. That means I'll have 3 to the power of s equal to 27, and 3 to the power of s, expressing 27 in index form is 3 to the power of 3. That is 3 times 3, 9, 9 times 3, 27. So the index form of 27 is 3 to the power of 3. And this is exponential equation. When the bases are the same, we equate the powers. On the other hand, if the powers are the same, we equate the bases. So in this case, the bases are the same, 3, 3. That means s is equal to 3. That is that for question A. Question B, we have log a to base 4. Let it be what? X again. That means 4 to the power of s is equal to 8. Expressing this in index form, I'll have 2 to the power of 2x equal to 2 to the power of 3. Excuse me. In this case, the bases are the same, so we can equate the powers. 2x equal to 3, meaning x is equal to 3 over 2. Finally, I have log, as question C now, log 0.04 to base 5. Let it be y. Let me use s again. I mean 5 to the power of s is equal to 0.04. Expressing this decimal number as a common fraction, I will have 5 to the power of s is 4 over, how many decimal places do I have here? 1, 2. That means I will divide by 100. So to convert a decimal number like this to a common fraction, we divide by power of 10 or multiples of 10, depending on the number of decimal places. If the decimal place is 1, we'll divide by 10 itself. If the decimal place is 2, we divide by 100. If it is 3, we divide by 1000. So in this case, I have 2 decimal places. That is why I have to divide by 100. So in this case, let's reduce the fraction. 4 here 1, 4 here 25, which means 5 to the power of x is equal to 1 over 25. 5 to the power of s equal to 1 over 5 to the power of 2, since 5 times 5 is 25. And the law of indices that says a to the power of negative n is 1 over a to the power of n. So as it is, our question is in this form. I will turn it to something like this, so that 5 to the power of s becomes 5 to the power of negative 2. Now the bases are the same, so we can equate the powers. Therefore, s is equal to negative 2 as our final answer there. Let's move on. Laws of logarithm. The first law is the law that says log m times n is equal to log m plus log m. In other words, if I have log m multiplied by m to base a, or to any base for that matter, is log m to base a plus log m to base a. Then I also have the law of division. M divided by n to base a will be log m to base a minus log n to base a. Then finally we have the law that says log, let me say p to power n to base a is n log p to base a. So we use these three laws to solve some problem. Now the first problem here says evaluate log 7 plus 2 log 2 minus log 280. Log 7 plus 2 log 2 minus log 280 will be log 7. Now apply the law that says log p to base to the power of n to base a is n log p to base a. So I have a term here that is in this form. I want to turn it to this. I'll have plus log 2 to the power of 2 minus log 280. And that will give me log 7 plus log 4, 2 to the power 2 is 4, minus log 280, which is applying the law that says log p to base a plus log q to base a equal to log p times q to base a. So we have an addition here. I'll turn it to multiplication. So I'll have log 7 times 4 minus log 280. And 7 times 4 is 28. So I have log 28 minus log 280. Final law that says log p minus log q to the same base is log p divided by q. So this is log 228 over 280. 28 here is 1. 28 here is 10. So I have log 1 over 10. Let's assume this is to base 10. You can solve further. Of course, when logarithm is written without any base, the base is 10. So it's not an assumption. So the base is 10 in this case. So let this equal to x. That means 10 to the power of s, expressing it in index form, is equal to 1 over 10, which you can write as 10 to the power of x equal to 10 to the power of negative 1. The bases are the same, therefore we can equate the power. S is equal to negative 1. Therefore, log 1 over 10 is equal to negative 1. And the second question there says, for the b, we have log 20 over 9 plus 2 log 6 over 5 minus log 4 over 125. That will be log 20 over 9 plus log 6 over 5 to the power of 2, applying the law that says equal to n log p to base a. So the question is like this. I turn it like this. That is what I did here. Minus 4 over 125. This will be log 20 over 9 plus log 6 squared is 36 and 5 squared is 25 minus log 4 over 125. That will be log 20 over 9 times 36 over 25 minus log 4 over 125. Let's reduce this. 5 here is 4, 5 here is 5. 9 here is 1, 9 here is 4. Will give us log 16, that is 4 times 4, over 5 minus log 4 over 125, which is log 16 over 5 divided by 4 over 125. That is, I apply the law that says log p minus log q is equal to log p over q. Over is the same thing as divide. So because I have fraction, I want to make it clearer there. So I have log 16 over 5. When we divide by fraction, the sign of division will change. Then we multiply to this by the reciprocal of this. I have 125 over 4. 4 here 1, 4 here 4. 5 here 1, 5 here 25. I have log 5 times 25 is 100, and log 100 is 2. So our answer is 2 there. We'll continue with example 14, which says, given that log 2 to base 10 is 0.3010 and log 3 to base 10 is 0.4771, evaluate log 9 to base 10, log 12 to base 10, and log 15 to base 10. For question like this, what we do is to express the log given to us in a way that we have a combination of any of these logarithms. What do I mean? Log 9 to base 10, for example, I can write 9 as 9 times 3 to the power of 2, then to base 10. Then if I apply the law that says log p to the power of n to base a is n log p to base a. If I apply it here, I will have 2 log 3 to base 10. And log 3 to base 10 is 0.4771. So substituting that into this place, I'll have 2 multiplied 0.4771, which is 2 times 1 is 2, 2 times 7 is 14, right? 4 carry 1, 2 times 7, 14 again, plus 1, 15, carry 1, 2 times 4 is plus 1, 9, 0.2 times this is 0. So our answer is 0.9542. So that's question number 1. Question A rather. Now move on to question B. This is log 12 to base 10. 12 to base 10, we can express 12 as log 4 times 3 to base 10. Then apply the law of logarithm that says log p q to base a is log p to base a plus log q to base a. If I apply it here, I have log 4 to base 10 plus log 3 to base 10. But I don't have any log 4 here. That means I still need to work on 4. 4 can be written as 2 to the power of 2 and to base 10 plus log 3 to base 10. If I apply this law again, this law to this place, I'll have 2 log 2 to base 10 plus log 3 to base 10. Now we can substitute the value log 2 to base 10 is here and log 3 to base 10 is right here. So this will be 2 multiplied by log 2 to base 10, which is 0.3010, then plus log 3 to base 10 is 0.4771. This will be 2 times this is 0.6020 plus 0.4771. And we add these two up together. We have, use a calculator to make it faster. 0.020 plus 0.4771 is 1.0791. 1.0791. The answer to that. I'll move on to question C there. What is the question? Let's write up here, okay? Let's clean this question. Question C. I have log 15 to base 10. Here, log 15 to base 10, I can write that as log 30 over 2. I'm doing that because if I say 15 is 5 times 3, I don't have log 5 here. And there's no way I can express 5 to get any of this combination. But 30 over 2, of course, I can express it to get a combination of this. So to base 10, this will be log 30 to base 10 minus log 2 to base 10. And log 30 to base 10 can be written as log 3 times 10. So that I'll have log 3 times 10 to base 10 minus log 2 to base 10, which is log 3 to base 10 plus log 10 to base 10 minus log 2 to base 10. Log 3 to base 10 is right here, 0.4771 plus log 10 to base 10 is 1 minus log 2 to base 10 is 0.3010. 1 plus this is 1.4771 minus 0.3010. That will give us 1.4771 minus 0.3020, 10, right? It's 1.1760. 1.1760. 1.1761, right? It's 1.1761. So that is all for question 14. Let's move on. 15 says, let me clean this question. 15 says, given that log 5 is equal to this and log 3 is equal to this, find log 45 without using mathematical tables. Log 45 will be log 9 times 5 to base 10, which is log 9 to base 10 plus log 5 to base 10. And log 9 to base 10 can be written as log 3 squared to base 10 plus log 5 to base 10, which is 2 log 3 to base 10 plus log 5 to base 10. And that gives me 2 multiplied by log 3 to base 10 is 0.477 according to what the value they give to us there. Then plus log 5 to base 10 is 0.699. 2 multiplied by this is 0.477 times 2 is 0.954 plus 0.699 and it was 1.653. 1.653. The answer there. The B part of this question says, hence solve x to the power of 0.8265 equal to 45. We take log to base 10 on both sides. So log 0.8265 to base 10 equal to log 45 to base 10. So that 0.8265 log s to base 10 is equal to log 45 to base 10. And log 45 to base 10 is 1.65 653 like we saw in question A. So I'm going to replace this now. 0.8265 log x to base 10 is equal to 1.653. That is the answer we got from the A part of this question. Dividing both sides by this, I have 8265 and 0.8265. Reduce the cancel. I mean log s to base 10 is equal to 1.653 divided by 0.8265 is 2. So now applying the law of logarithm by converting this to index form, s will be 10 to the power of 2, which is 100. So x, excuse me, is 100 in this case. Then we'll move on to the next question. Let us say find the value of x given that log s to base 10 plus log x plus 3 to base 10 is equal to 1. So apply the law of logarithm that say log p plus log q is log p times q. And we have this place as log s times s plus 3 to base 10 equal to, and logarithm of 10 to base 10 is 1, or I can even leave it as equal to 1. Now expressing this in index form, I'll have, before I do that, let me distribute this as, I'll have log s squared plus 3s to base 10 equal to 1. That means s squared plus 3s is equal to 10 to the power of 1, which is 10. Excuse me. S squared plus 3s minus 10 is equal to 0. This is quadratic now. So solving this quadratic equation, we have first of all, this multiplied by this is negative 10s squared We look for two factors of negative 10x squared that can add up to this middle term, which is 5 and negative 2x. 5x and negative 2x, when added together, will give us this middle term. So replacing that middle term with it, I'll have minus 2s minus 10 equal to 0. Factorizing this, I'll have s into s plus 5 minus 2 into s plus 5 equal to 0. S plus 5 and s minus 2 equal to 0. S plus 5 equal to 0 or s minus 2 equal to 0. S is minus 5 or 2. That is the answer to that. Minus 5 or 2. That is question 17. Now we'll move on to question 16. Oh, I actually rearranged them wrongly. It's supposed to be become first. Okay, for this, we have log k minus log k minus 2 equal to log 5. This means log k over k minus 2 is equal to log 5. Here, since we have, when the logarithm is given like this without a base, the base is 2 base 10. We have log to base 10 on both sides, so they can cancel out, so that k over k minus 2 is equal to 5. This implies k is equal to 5 times k minus 2. K therefore is 5k minus 10. Collecting like terms, k minus 5k is equal to minus 10. Minus 4k is equal to minus 10. Divide both sides by minus 4. This is also k is equal to 10 divided by 4, which you can write as 2 on the half. The first one here, we have log root 35 to base 10 plus log root 2 to base 10 minus log root 7 to base 10. Or if I apply the laws of logarithm, this first one here will be log root 35 times root 2 to base 10 minus log root 7. And that will be log root 35 times root 2 is root 70. That is solved. Root a times root a is root a times, okay, let me use b here. Root a times root b is root a times b. So root 35 times root 2 is 35 times 2, then under the square root, then minus log root 7 to base 10. This is to base 10. Now that will be log root 70 over root 7 to base 10. Again, solve. Root a over root b is root a over b. So this will be log root 70 over 7 to base 10, which is root 70 over 7 is 10. So root 10 to base 10. Let's assume this is equal to s. That means 10 to the power of s, I'm expressing it in index 1, the square root of 10. On square root of 10, I can write as 10 to the power of half. So 10 to the power of s is 10 to the power of half. The bases are the same. See half and I root s. 10 to the power of s equal to 10 to the power of half. The bases are the same. So we equate the power. S is equal to half. We have log 3 over 5 to base 5 plus 3 log 15 over 2 to base 5 minus log 81 over 8 to base 5, which is log 3 over 5 plus is to base 5 plus log 15 over 2 to power 3 to base 5 minus log 81 over 8 to base 5, which is log 3 over 5 to base 5 plus log 15 to the power of 3, 3375, 3375, and 2 to the power of 3 is 8, minus log 81 over 8 to base 5. Now adding this logarithm will imply we are going to multiply their logarithm. So I have log 3 over 5 multiplied by 3375 over 8 and minus log 81 over 8, which will be log 3 over 5 multiplied by 3375 over 8, then the whole of this divided by 81 over 8. I don't want to multiply this because I want to reduce the fraction as much as I can. This will be log 3 over 5 multiplied by 3375 over 8 times 8 over 81. 8 here, 1, 8 here, 1. Let's see whether 3375 divide 81. Divide by 81 doesn't. Let's reduce. Let's see if it's supposed to divide 5 since it's a let's say multiple of 15. 3375 divided by 5 is 675. So 5 here, 1, 5 here, 675. Let's see what else can divide. 3 here, 1, 3 here, 27. So we have log 675 over 27 to base 5. So we have log 675 over 27 to base 5, and 675 divided by 27 is 25. I have log 25 to base 5. Log 25 to base 5, let it be x, meaning 5 to the power of s is equal to 25, which implies 5 to the power of s equal to 5 to the power of 2. S is equal to 2. Therefore, our answer to that question is 2. Then the m part, let me clear this box so we have. Okay, m says log 350 minus log 7 plus log 2. Let's rearrange it first. Let's bring all the positives together. So I have log 350 plus log 2 minus log 7. That will be log 350 times 2 minus log 7. 350 times 2 is 700. log 700 minus log 7, which is log 700 divided by 7 is log 100, and log 100 is 2. The next one, say assuming only that log 2 to base 10 is this, log 3 to base 10 is this, and log 7 to base 10 is this. Evaluate each of these. The first one we have log 8 to base 10, which you can write as log 2 to the power of 3 to base 10, which is 3 log 2 to base 10. That is 3 multiplied by 0. Log 2 is 0.3010, which is 0.9030. That is A. For B, we have log 81 to base 10. 81 we can write that as 3 to the power of 4, then to base 10, which is 4 log 3 to base 10. That is 4 multiplied by log 3 to base 10 is 0.4771. 4771. And 4 multiplied by 0.4771 is 1.9084. 1.9084. And for question C, we have log 8.1 to base 10, which you can write as log 8.1 to base 10 is 81 over 10 to base 10, which is log 81 to base 10 minus log 10 to base 10. 81 to base 10 is log 3 to the power of 4 to base 10, then minus log 10 to base 10. This will be 4 log 3 to base 10 minus 1. Log 10 to base 10 is 1, which is 4 times log 3 to base 10, which is 0.4771, and minus 1, 0.4771 minus times 4 rather is already here, which is 1.9084, then minus 1. That will be 0.9084. That is question C. Now for question D. D we have log 40 to base 10, which I can write as log 4 times 10 to base 10. And that will be log 4 to base 10 plus log 10 to base 10. Now 4 to base 10, we can write as log 2 to power 2 to base 10 plus log 10 to base 10. 2 to power 2 to base 10 is 2 log 2 to base 10 and plus excuse me, log 10 to base 10, which is 2 multiplied by 2 to base 2 is right here is 0.3010, then plus 1, 2 multiplied by this 0.6020 plus 1, which is 1.6020. And then question E. For E we have log 21. We can write this as 3 times 7 to base 10, which is log 3 to base 10 plus log 7 to base 10. That will be log 3 to base 10 is 0.4771, and log 7 to base 10 is 0.8451, Let's add up these numbers together. 0.4771 plus 0.8451 is 1.3222. 3222. Then question F, we have log square root of 60, not 10, square root of 60 to base 10, which you can write as log 60 to the power of half to base 10, which you can write as half log 60 to base 10. Now, and 60 to base 10, we can write that as 6 times 10. So we have half multiplied by log 6 times 10 to base 10. Now I put this half outside this bracket because it's going to multiply everything here. And that will be half bracket log 6 to base 10 plus log 10 to base 10, which is half multiplied by log 6 to base 10. 6 to base 10 is not given here. That means we still need to work on that. I'll have log 2 times 3 to base 10, then plus log 10 to base 10, which is half multiplied by log 2 to base 10 plus log 3 to base 10 plus log 10 to base 10. And that will be half multiplied by log 2 to base 10 is right here, 0.3010 plus log 3 to base 10 is 0.4771 plus log 10 to base 10 is 1. So adding all of this together, we have then divided by half, divided by 2 rather, is 0.8891 approximately. Okay, that is question F. Let's move on to question G. For question G, we have log 37.5 to base 10, which you can write as log 75 over 2, because 75 divided by 2 is 37.5. So if I write this as 75 over 2 to base 10, that will be log 75 to base 10 minus log 2 to base 10. See, we have log 25 multiplied by 2 to base 10 minus 25 multiplied by 3, not multiplied by 2. 75 multiplied by 3, and minus log 2 to base 10, which is log 25 to base 10 plus log 3 to base 10 minus log 2 to base 10. So in this case, let us take the value of log 25. Log 25 is 1.3979. Then plus log 3 to base 10 is 4771 minus log 2 to base 10 is 0.3010. Adding up this, I'll have 0.3010 4771, then minus 0.3010, which is 0.3979 minus plus rather plus 0.4771, then minus 0.3010, 1.574. For question H, we have log 12.25 to base 10. Now 12.25, I can write that 12.25 multiplied by 4 gives me 49. So I can write this as log 49 divided by 4 to base 10. Why am I doing that? I want to have a combination of 2 and 7. 49 divided by 4 is 49 divided by 4 just give us 12.25. So we can write this as log 49 to base 10 minus log 4 to base 10, which is log 7 squared. That is 7 times 7 is 49 minus log 2 squared. 2 times 2 4 to base 10. And this we can write as 2 log 7 to base 10 minus 2 log 2 to base 10, which is 2 multiplied by log 7 to base 10 according to the question is 0.8451. Then minus 2 times 2 to base 10, that is 0.3010, which is 2 multiplied by this 2 times 0.8451 is 1.6902. 1.6902 minus 0.6020 minus 0.6020, 1.0882, 1.0882. Okay, that is the answer to that. Question H, and this H I just saw. I this time around, I have log 0.72 to base 10. And this I can write as log 72 over 12 over 100 to base 10, which is log 72 to base 10 minus log 100 to base 10. 72, we can write that as 36 times 2 to base 10, then minus log 100 to base 10. And this will be log 36 to base 10 plus log 2 to base 10 minus log 100 to base 10. 36 I can express that as 9 times 4. 9 times 4 to base 10 plus log 2 to base 10 minus log 100 to base 10, which is log 9 to base 10 plus log 4 to base 10 plus log 2 to base 10 minus log 100 to base 10. Here we have log 9 to base 10. I write that as 3 squared to base 10 plus log 2 squared to base 10, that's 4, log 2 to base 10 minus log 100 to base 10. And this gives us 2 log 3 to base 10 plus 2 log 2 to base 10 plus another log 2 to base 10 minus log 100 to base 10. And this is 2 log 3 to base 10. This and this can be added since both of them are log 2 to base 10 plus 3 log, that is 2 plus 1, 2 to base 10 minus log 100 to base 10. And what is log 3 to base 10? 4771. 2 times 0.4771 plus 3 times 0.3010 minus log 100 to base 10 is 2. 2 multiplied by this will give us 2 times 0.4771 is 0.9542. 9542 plus 0.9030 minus 2 plus 0.9030 and minus 2 is minus 0.1428. The answer is negative. Okay, that is the end of that question. Let's move on to more questions down here. Question 4. We have simplified the following without using tables. So the first one we have log 8 over log 2. We can write this as log 8 can be written as 2 to the power of 3, 10 over log 2. And log 2 to the power of 3 is both of them are logarithm to base 2 will be 3 log 2 over log 2. So log 2 can cancel log 2, so our answer is 3. Then for the second one, B, we have log 27 over log 9. This I can write as log 27, that is 3 to the power of 3 over log 9 is 3 to the power of 2, which you can write as 3 log 3 over 2 log 3. So log will cancel log, and we are left with 3 over 2, which is 1.5. That is that for A and B. C, we have log square root of 8 over log 4. This you can write as log 8 to the power of half over log 4, and 8 to the power of half again, I can write that as half log 8, I will write it as 2 to the power of 3, then 4, I will write it as 2 to the power of 2, which is, now this 3 multiplied by half is 3 over 2 log 2 over 2 log 2. So log 2 can cancel log 2. So we have 3 over 2 divided by 2. over 1. These two down here is 3 over 2 times 1 over 2, which is 3 over 4. So our answer there is 3 over 4. Then question D. Question D, let's get rid of this please. Question D, we have log 5 over log 0.2. This we can write as log 5 over log 2 over 10. And log 2 over 10, that is log 5 over log 1 over 5. That is 2 here 1, 2 here 5, which I can write as log 5 over log 5 to the power of negative 1, because a to the power of negative 1 is 1 over a. So I have 1 over 5 here. I turn it to this, and this is log 5 over negative 1 log 5. So log 5 can cancel log 5, and that will be 1 divided by negative 1, which is still negative 1. Log 5 divided log 5 is 1. 1 divided by negative 1 is negative 1. For E, we have log 8 minus log 4 all over log 6 minus log 3. Log 8 minus log 4 is log 8 divided by 4, and log 6 minus log 3 is log 3 divided by 3, which is log 2 over log 2, which is 1. Because 8 divides 4 is 2, and 6 divides 3 is 2. So log 2 divided by log 2, which is 1. Log question G now. I have log 81 over log 1 over 3. This I can write as log 3 to the power of 4 over log 3 to the power of negative 1, which is 4 log 3 over negative 1 log 3. So log 3 can cancel. 4 divided by negative 1 is negative 4. That is our question G. Question H now. H we have log 30 over 16 minus 2 log 5 over 9 plus log 400 over 243. Applying the laws of logarithm, this will be log. Since this number can divide, let's reduce it so that it will make our work easier. 2 in this is 15, 2 in this is 8, then minus these 2 will come here. So I'll have log 5 over 9 to the power of 2, applying law of logarithm, plus log. There's nothing that divides 400 and 243, so it's still going to remain as 400 over 243. Okay, which gives us log 15 over 8 minus log 5 squared is 25, 9 squared is 81, plus log 400 over 243. Let me bring out the positive first. That is, this and this are positive. So I will have log 15 over 8 plus log 400 over 243, and minus log 25 over 81. Applying the law of logarithm, that will be log 15 over 8 multiplied by 400 over 243, or minus log 25 over 8. Let's reduce again. 4 here 1, 8 here rather 1. 8 in 40 is, I think it's 50. 400 divided 8. 50. Okay, so here I have log 15 times 50 over 243 divided by 25 over 8. I'm applying the laws of logarithm. And when we divide one fraction by another fraction, we should know what will happen to division. So I'll have log 15 times 50 over 243 multiplied by 8 over 25. Let's see if we can reduce. 25 here 1, 25 here 2. 15 times 2 is 30. 30 times 8 is, that should be 240 also. 30 times 8, yep, 240. We log 240 over 243. And I don't think there's any number that divides this. We are going to leave this as that. Okay, that is that for question 8. Let's move on to the last one in this. So the first one in this group is solve the following equations for x. The first equation, log 10, that is log s to base 10 rather, is equal to 3. This implies s is equal to 10 to the power of 3, s equal to 1000. I have this in logarithmic form. I express it in index form. 10 to the power of 3 is equal to x. That is graph for A. Then the B says log 27 to base s equal to 3. Expressing this in index form. That means s to the power of 3, this to the power of this, equal to 27. S to the power of 3 equal to 3 to the power of 3. That is 27 is 3 to the power of 3. So in the power of the same 3, 3, we can equate the basis s is equal to 3. On question C, we have log 1 over 16 to base s equal to negative 1 over 2. So expressing this in index form, s to the power of negative 1 over 2 is equal to 1 over 16. This implies that to remove these negative indices or negative index, that will be 1 over x to the power of half equal to 1 over 16, which means x to the power of half is equal to 16. I cross multiply 1 times this is still 1 x to the power of half, and 1 times 16 is still 16. To remove this half here, I'll multiply both power by 2. So this multiplied by 2 and 16 to the power of 1 multiplied by 2. So this can go, x is equal to 16 to the power of 2, that's 16 times 16, which is 256. So s is 256. Move on to d. D is 3 to the power of s equal to 1. To make the basis equal here, we know that any number raised to the power of 0 is 1. So I'm going to raise this become 3 to the power of 0. These and these are equivalent. Now the bases are the same, which implies x is equal to 0. In question E, we have 4 to the power of x plus 1 equal to 8 to the power of x. Expressing each of these in index form, if I express this in index form, I have 2 to the power of 244, then multiply by this x plus 1 equal to 2 to the power of 348, multiply by this s, which is 2 to the power, 2 times x is 2x, and 2 times 1 is 2, equal to 2 to the power of 3x. This implies the bases are the same, so we can equate the powers. 2s plus 2 is equal to 3x. Collecting items, 2x minus 3x equal to minus 2. As I move this across the equality become minus. I also move this across the equality become minus. Okay, 2x minus 3x is minus x equal to minus 2. Minus will cancel out. Therefore, s is equal to 2. Okay, we have question F now. And F says 2 to the power of x multiplied by 2 to the power of 3x minus 1 is equal to 1. Now, applying the first law of indices a to the power of s times a to the power of y, for example, is a to the power of s plus y. If I apply it here, I'll have 2 to the power of s plus 3s minus 1 equal to 1, which is 2 to the power of x plus 3s is 4s, then minus 1 equal to any number to the power of 0 is 1, so this one I will turn into 2 to the power of 0 so that the bases will be equal. Now the bases are the same, we can equate the powers. 4s minus 1 is equal to 0. That means 4s is equal to 1. Divide both sides by 4. S is equal to 1 over 4. So in this 4 we cancel this. That is question F. Now let's do question G here. So this place will be enough. G says 2 to the power of 2x minus 3 times 2 to the power of x plus 2 equal to 0. And this one is going to lead us to quadratic equation. And before we do anything, let me adjust this first term here so that I have 2 to the power of s, because I have 2 to the power of s here. So this 2 to the power of 2s, I can write it as 2 to the power of s to the power of 2 and minus 3 times 2 to the power of s plus 2 equal to 0. I have 2 to the power of s here, I have it here, so I can substitute it with anything. Let me use p. Let p be equal to 2 to the power of s, so that this place now becomes p squared. Now the musician minus 3 times p, since I have another 2 to the power of s there, and plus 2 equal to 0. Okay? Now, this is quadratic, so let's solve that. P squared times 2 is 2p squared. Then we look for two factors of 2p squared that can add up to this. Factors of 2 are just 2 and 1. So 2p and 1p. How do you add 2p and 1p to get minus 3p? Both of them have to be minus. Now that I know the factors, I'll replace this middle term with the factors, so that I have p squared minus 2p minus p plus 2 equal to 0. Now if I group this 2 by 2, that is the p squared minus 2p minus p minus 2. This plus change to minus because I introduce a bracket. Now p is common there, so p minus 2. Here 1 is common, p minus 2 equal to 0. And p minus 2 and p minus 1 equal to 0. You see that p minus 2 is equal to 0, or p minus 1 is equal to 0. P therefore is 2 or 1. But it's x we are looking for. So now that we know p, we said earlier that p is 2 to the power of x. So that p is 2 to the power of x. So when p is, what were the value of p? 2 and 1. When p is equal to 2, that means 2 to the power of x is equal to 2. The power of 2 here is 1. Even when it is not written, we know that the power is 1. The bases are the same, so x is equal to, we equate the power, x is equal to 1. Again, when p is equal to 1, 2 to the power of x is equal to 1, which implies 2 to the power of x. I'm turning this one to 2 to the power of 0, since I know that any number to the power of 0 is 1. I'm doing that so that the bases will be the same. So now we have the bases to be equal. We can equate the powers. S is equal to 0. Therefore, the final answer to that question is S is equal to 0 and 1. Okay, now we'll move on to question number. We just solved question 3, so we'll move on to H. Question H is 3 to the power of 2x plus 6 times 3 to the power of x minus 27 equal to 0. Again, I have 3 to the power of x here, so I will adjust this first term so that I will have 3 to the power of s in both sides. I will replace it. In this first term, we can write that as 3 to the power of s, then to the power of 2 plus 6 times 3 to the power of x minus 27 equal to 0. So I have 3 to the power of s here, I have it here, I can replace it. Again, let me use p. So here the first one will be, okay, let me write this, let p be equal to 3 to the power of s. The first term then becomes p squared, 6 times p minus 27 equal to 0. This is quadratic. Multiply the first term by the last term, that's minus 27p squared. Look for two factors of minus 27p squared that can add up to this middle term plus 6p. That should be 9p and 3p. Since 9 times 3 is 27, but how do we add 9p and 3p to have this? This has to be plus and this has to be minus. So that now that we know the factors, we'll replace the middle term, not terms. Middle term with the factor. So I'll have p squared plus 9p minus 3p minus 27 equal to 0. If I group these 2 by 2, I will have minus 3p plus 27 equal to 0. You notice that this minus change to plus because of the bracket I introduced. We can factor the common factor p is common here. P into p plus 9 minus 3 into p plus 9 equal to 0. P plus 9 is common, equal to 0. That means p minus plus 9 rather is equal to 0, or p minus 3 equal to 0. P therefore is minus 9. When this one comes here, that is 0 minus 9 is minus 9, or p equal to 3. When this comes here, it becomes 0, 0 plus 3, which is 3. But p is 3 to the power of x. So let's go back there. P is 3 to the power of x. When p is equal to 3, which is one of the values we just calculated, 3 to the power of x is equal to 3 to the power of 1, meaning s is equal to 1. When p is equal to minus 9, 3 to the power of s equals to minus 9. In this case, there is no solution. There is no way a positive number will become equal to a negative number. It's not possible. So there's no solution here. The only solution that satisfies that equation is s equal to 1. Let's move on to the next one. We are in I now, question I. Question I says 2 to the power of 2x plus 1 minus 9 times 2 to the power of x plus 4 equal to 0. Here, because of this plus 1 here, I will write it as 2 to the power of 2x times 2 to the power of 1. Applying the first law of indices, if I have 2 to the power of 2s times 2 to the power of 1, and I want to turn it to a singular indices. That should be 2 to the power of 2s plus 1, which you already know. So our question is in this form. I split it up to this form. Then minus 9 times 2 to the power of s plus 4 equal to 0. Now, this 2 to the power of 2s, we can still write it as 2 to the power of s, then to the power of 2, then multiply by these 2 right here, minus 9 times 2 to the power of s plus 4 equal to 0. I want to replace 2 to the power of s now, so let it be p. Let p be 2 to the power of x, so that anywhere I see 2 to the power of s, I'm going to replace it with p. So the first one here will be p squared. Then p squared times this 2 will be 2p squared. Minus 9, again this is another 2 to the power of s. 2 to the power of s is now p. P times 9 is 9p. Plus 4 equal to 0. Again we arrive at quadratic equation. 2p squared times 4 is 8p squared. 2 factors of 8p squared that can add up to 9. That should be 8 and 1. So 8p and 1p, both of them have to be minus. So we're looking for minus 9. So that this equation now becomes 2p squared minus 8p minus p plus 4 equal to 0. If we group it 2 by 2, we have this, and p minus 4 equal to 0. 2p is common here. 2p into p minus 4. Then here 1 is common. P minus 4 equal to 0. We have a common factor p minus 4. Then we'll group the other one together, equal to 0. Either p minus 4 is equal to 0 or 2p minus 1 equal to 0. P is 4 or 2p is 1. P is 4 or dividing both sides by 2 here, or p is half. We'll go back to the value of p, which is 2 to the power of x. So when p is equal to, what are the value of p? 4 or half. When p is equal to 4, that means 2 to the power of s is equal to 4, which implies 2 to the power of s is 2 to the power of 2, 4 expressed in index form. The bases are the same, so we put the powers. S is equal to 2. Again, when p is equal to half, that means 2 to the power of s is equal to 1 over 2. 2 to the power of s is 2 to the power of negative 1. S is equal to negative 1. So the values that satisfy this equation is s equal to 2 and s equal to negative 1. Question J is 6 log x plus 4 equal to log 64. This you can write as log x plus 4 equal to log 64. I can write that as 2 to the power of 6. 2 to the power of 6. Because 2 to the power of 6 is 2 to the 2 times 2 times 26, which is 64. And that will be 6 log s plus 4 equal to 6 log 2. This 6 will cancel out. So that I have log x plus 4 equal to log 2. The log will cancel. S plus 4 equal to 2. S equal to 2 minus 4. S is minus 2. Okay, I have 9 to the power of 2s plus 1 equal to 81 to the power of x minus 2 all over 3 to the power of x. Okay, I'm going to cross multiply here. So I'll have 9 to the power of 2x plus 1 multiplied by 3 to the power of x equal to 81 to the power of x minus 2. Now reducing this to index form, that is 3 to the power of 2, then multiply by this 2x plus 1, multiply by this 3 to the power of x equal to, I'll reduce this to index form to 3 to the power of 4, then multiply by this s minus 2, which will give me 3. Now distributing this to 2 times this is 4s, then 2 times this is 2, multiply by 3 to the power of s equal to, distributing this 4, I'll have 4s minus 8, so that 3 to the power of 4s plus 2, then plus this s, I'm applying the first law of indices, for the 3 to the power of 4s minus 8, 4s plus s is 5s, so I have 3 to the power of 5s plus 2 is equal to 3 to the power of 4s minus 8. The bases are the same, so we put the powers plus 2 equal to 4s minus 8. Collecting like terms, 5s minus 4s equal to negative 8. This one comes here become minus 2. So that's 5s minus 4s is s equal to negative 10. For L, we have log 2x plus 1 to base 10, what is it, minus log 3x minus 2 to base 10 equal to 1. Okay, log 2s plus 1 to base 10 minus log 3s minus 2 to base 10 equal to 1. Applying the law of logarithm, we have one of the laws of logarithm. We have 2x plus 1 over 3x minus 2 to base 10 equal to 1. I'm going to turn this now to index form. Logarithm of a number p to base a is the index x to which a must be raised to be equal to p. That means 2s plus 1 over 3s minus 2 is equal to 10 to the power of 1, which is 10. Excuse me. Cross multiply, I'll have 2x plus 1. Remember, this 10 is over 1. 2s plus 1 is 2s plus 1 equal to 10 multiplied by this 3x minus 2. So 2x plus 1 is equal to 30x minus 20. 10 times 3 is 30, and 10 times negative 2 is negative 20. Collecting like terms, 2x minus 30 is equal to minus 20 minus 1. 2x minus 30 is minus 28. X equal to minus 21. Divide both sides by minus 28. Minus 28. Here we go. S equal to 7 here 3, 7 here 4. So S is 3 over 4. Now question M, we have 3 multiplied by 9 to the power of 1 plus x equal to 27 to the power of negative s. This will give us, expressing this in index form, that is 3 squared, then multiply by 1 plus x equal to, expressing 27 in index form is 3 to the power of 3, multiplied by negative s is negative s. So that will be negative 3s rather. Okay, now the power of this 3 here is 1. Before that, let me distribute these 2 here. So I'll have 3 to the power of 1 multiplied by 3 to the power of 2 plus 2s equal to 3 to the power of negative 3s. So that when we apply the first law of indices here, we have 3 to the power of 1 plus 2 plus 2x equal to 3 to the power of negative 3x. Which gives us 1 plus 2 is 3, 3 to the power of 3 plus 2s equal to 3 to the power of negative 3s, which gives us 3 to the power. Okay, the bases are the same, so let's equate the powers. 3 plus 2s equal to negative 3s. Collecting items 3 is equal to negative 3s on minus 2 minus 2x. 3 equal to negative 5x. Divide both sides by negative 5. So this can go. S therefore is negative 3 over 5. Then finally, the last question, which is n, says log 3x minus 1 to base 10 minus log 2 to base 10 equal to 3. If I apply the first law, one of the laws of logarithm, I'll have to divide this. So I'll have log 3x minus 1 over 2 to base 10 equal to 3, which when I convert this to index form, I will have 3x minus 1 over 2 equal to 10 to the power of 3. And that will give me 3x minus 1 over 2 equal to 10 to the power of 3 is 8,000. Cross multiply 3x is equal to 1,000 times 2. 3x or minus 1 rather, minus 1 is equal to 2,000. S equal to 3s equal to 2001. That is this one, come here and add s will be 2001 divided by 3, which is 667. And that brings us to the end of this lengthy tutorial.